Alright, 2.4 through 2.5, we're looking at product rule, quotient rule, chain rule, and higher order derivatives. So, first thing we're going to look at are the product and quotient rules. So the product rule says if you've got a product of two functions, then the derivative will be the derivative of the first times the second plus the first times the derivative of the second. And you'll see that the quotient rule is similar. If you're dividing two functions, then the derivative would be almost the product rule except subtraction. And then you divide the whole thing by the second function or the bottom function squared. So those are things that you'll just have to memorize. And these rules are good because they, excuse me, get my pen here. They make it easier for us to take derivatives. In some cases, you could take a derivative by multiplying it out or dividing it out, but usually it's easier just to use the product or quotient rules. So in this example, this would be my f, and this would be my g, so the first and the second functions. So I would take the derivative of the first, which is negative 56 x to the 7th power plus 20 x cubed, and I multiply that by the second one. Now don't be nervous because we don't actually have to multiply that all out. And then we do plus the derivative of the second one, which is 6e to the x, all that times the first. Okay, so we have the first, or the derivative of the first, times the second, plus the derivative of the second times the first. Then you'll notice that I switched these around, but multiplication is commutative, so it doesn't matter which one I list first. In this case, it was convenient to list g prime first because it was just a singular term as opposed to having two, and usually we write those out in front. And you could also technically take this whole thing and this whole thing and swap those because addition is also commutative. So as long as you are taking the derivative of one times the other and adding it to the derivative of the other times the first one, then you're using the product rule correctly. So it's kind of hard to mess up. Now the quotient rule, I'm going to call f the top function and g the bottom function. So the derivative of the top is negative 25 x to the 4th power minus 16 x cubed minus 20, no, 3 times 3 is 9, 9x squared. That is the whole derivative of the top. And then the bottom is the bottom, x to the 4th plus 5. And we're going to subtract the derivative of the bottom, which is 4x cubed, and multiply that by the top. And the whole thing is over x to the 4th plus 5 squared. And that's it. You do not need to simplify these. Just be really careful when you're entering them in My Open Math. Alright, one more product rule. So derivative of the first is 2t plus 6 times the second, 3t squared plus e to the t, and we're going to add derivative of the second, which is 6t plus e to the t times the first. First is t squared plus 6t plus 3. And again, you do not need to simplify. That is just fine the way it is. Alright, the dose response for a specific drug is f of x equals 100x squared over x squared plus 0.06, where f of x is the percent of relief obtained from a dose of x grams of a drug. and x is going to be between and include 0 to 1.5. We want to find f of 0.4. Alright, so the derivative of f of x is going to be derivative of the top, 100x squared, derivative would be 200x. Multiply that by the bottom, that's x squared plus 0.06. Subtract the derivative of the bottom, which is 2x, and multiply that by the top, 100x squared. And divide the whole thing by the bottom squared, which is x squared plus 0.06 all squared. Again, we don't have to simplify. We just need to plug in 0.4. So you put 0.4 everywhere you see an x. And if done correctly, you should get 99.17. It says, and select the appropriate units. So we don't have a selection, so we're just going to come up with the appropriate units ourselves. So this function is percent of relief obtained from x grams of a drug. So our units are going to be its rate of change, so it's going to be how much the percent relief is changing. So the dependent variable over the number of grams of the drug. So percent per relief per gram. Alright, the chain rule. This is copied from your book. It's a little complicated, so I try to sort of clear it up down here. Although I like this one here. It says the derivative of a composition is the derivative of the outside with the inside staying the same times the derivative of what's inside. So that's, really what we want to look at. Remember, we learned about the outside function and the inside function before, and this is very important for the chain rule. So if I have f of x equals 3x minus 5 to the 23rd power and I want to take the derivative, the inside function is the 3x minus 5 and the outside function would be x to the 23rd. It's composed of those two functions. So we let u be the inside function, so u is equal to 3x minus 5, and we can rewrite it as f of u is u to the 23rd power. Now it's easy to take the derivative of that, it's just 23u to the 22nd power. However, you need to multiply that by the derivative of whatever u is, and that's the chain rule. So we get 23u to the 22nd power times dd du. And the derivative of 3x minus 5 is just 3. So d du is just 3. So f prime of x is going to be 23 times the quantity 3x minus 5 to the 22nd power times 3. And if you combine the 3 and the 23 together by multiplication, you get 69 times 3x minus 5 to the 22nd power. So let's look at some more examples of that. Here we're going to take the derivative, use the power rule as normal, so the 2 comes down in front, and we get 2 times x squared plus 5x plus 8, all to the first power, and then we multiply by the derivative of the inside, which is 2x plus 5. And we're done. That's what the derivative of x squared plus 5x plus 8 quantity squared is. B, f of x equals the square root of 5x squared plus 5x plus 8. Let's make it derivative friendly first. Let's take all of that, the 5x squared plus 5x plus 8. We're going to write that all to the 1/2 power. Alright, again, the 1/2 comes down in front, so f prime of x is equal to 1/2 times the inside to the negative 1/2. And that gets multiplied by the derivative of the inside, which is 10x plus 5. With the e, if it's just plain old e to some variable, like e to the x, then the derivative is e to the x. But if you put a negative in front there, you need the chain rule. So the derivative of dq is going to be e to the negative q, because the derivative of e to the anything is itself, but then you have to multiply by the derivative of the inside, and the inside is that negative q. So the derivative of negative q is negative 1. So we get negative e to the negative q. Similarly with d, we have f of x is equal to 5e, and the power is 9x to the 10th plus 6x to the 7th. Alright, so we're going to get, you always start by just rewriting the problem, because the derivative of e is itself. And then the inside is going to be that exponent on e. This one here. So we have to multiply all that by 90x to the 9th power plus 42x to the 6th power. Alright, and I'm going to just put this in parentheses so it's clear. H of x is equal to quantity 3x plus 5 to the 10th. So h prime of x is going to be 10 times 3x plus 5 all to the 9th, and then times 3. So it's easy to combine the 3 and the 10 and get 30. Combine, I mean multiply. So 30 times quantity 3x plus 5 to the 9th power. And g of x, we've got the quantity x plus 6 over the quantity x plus 5 all to the 4th power. So we're going to get 4 times the inside all to the 3rd power, and then times the derivative of the inside. The derivative of the inside is the quotient rule. So it's the derivative of the top, which is 1, times the bottom. So you just get x plus 5. Then minus the derivative of the bottom, which is 1, times the top. So you get minus x and minus 6. Now the reason they're both negative is because you have to put that subtraction all the way through, over the bottom squared. Now I notice I have an x and a minus x, and we know that those are going to cancel, and 5 minus 6 is negative 1. So that negative 1 can go with the 4 out here, and we get just negative quantity x plus, oh boy. Wasn't trying to get a note there. X plus 6 over x plus 5 to the 3rd power times 1 over x plus 5 squared. So I combined the quotient rule and the chain rule. Alright, some applications of this. We have the radius of a circular oil spill after t minutes is given by r of t equals the square root of 16t. Find the instantaneous rate at which the radius is growing after 26 minutes. So what we need is r prime of t. And since the square root is the same as the 1/2 power, I'm going to get 1/2 times 16t to the negative 1/2 power, and times derivative of the inside, which is 16. 16 times 1/2 is 8, so we get 8 times 16t to the negative 1/2. And then we plug in 26 So 8 times 16 times 26, all to the negative 1/2, is 0.392. During the first couple of weeks of a new flu outbreak, the disease spreads according to that equation. I of t equals 4,300 e to the 0.036 t, where I of t is the number of infected people t days after the outbreak was first identified. Find the rate at which the infected population is growing 11 days after 11 days and select appropriate units. So I prime of t is going to be, we need to take that 0.036 and multiply it by 4,300, and we get 154.8. I inadvertently added a sticky note. Let's see if I can get rid of it. There we go. 154.8 e to the 0.036 t, and then we have to multiply by the derivative of the inside, which is the power on e, so it's 0.036. And we don't really need to worry about, oh, actually, this, let me get my eraser here. That's not correct. That's after you multiply the 0.36. So let me do it out here. 4,300 times 0.036. 154.8. Oh, it was right. Okay, yeah, I'm sorry. This is what we don't want because we already did that multiplication. Alright, we're good now. I prime of, what do we want? 11. So just stick 11 in there. And if you punch this in your calculator, you should get 230.01 days. So it's day, let's see what the units are, number of infected people per day. Not days, but day. Alright, at a price of X dollars, the supply function for a music player is Q equals 80 e to the 0.003x, where Q is in thousands of units. How many music players will be supplied at a price of 225? That first one, all we need to do is, we're trying to find the price at 225, so we just plug that in to the original. So notice it's not talking about rate of change there. You have to be able to distinguish between those two. And that is going to be 157 units. So run around to the nearest thousand. And then the marginal supply, that's going to be Q prime. So we're going to do 80 e to the 0.003 and multiply, x, we need an x in there. Multiply by the derivative of the inside, which is 0.003. And cleaning that up, you get 0.24 e to the 0.003x. Alright, higher order derivatives mean that we can take the first, second, third, fourth derivative and so on, in this class we only need to find the second derivative for the applications we're going to be doing. So find the second derivative, you got to start by finding the first derivative. So we get, for first derivative here, it's going to be 4x cubed plus 6x squared plus 6x plus 4. The second derivative would be the derivative of that, so 12x squared plus 12x plus 6. And then you just want to plug 1 in for both of these, so 4 times 1 cubed plus 6 times x 1 squared plus 6 times 1 plus 4. So that's going to be 4 plus 6 is 10, plus, oh, there should have been another 6 there. Six times 1, so it's 16, and another 4 is 20. And if we plug 1 in for the second one, that's 12 times 1 squared plus 12 times 1 plus 6. So 12 plus 12 is 24, plus 6 is 30.